These are your 5-7 video notes on solving radical equations. Radical can also be thought of as a root, so when you see the word radical, think of it as square root, third root, fourth root, and radical interchangeable ideas. The first thing we're going to do is talk about how you eliminate a root, because part of solving the radical equation will be to get rid of the root as part of the process. And the way you get rid of a root, if you think back to chapter 4, I don't know if you guys remember us talking about that back in chapter 4, but basically want to square. Square and a square root are opposite operations, and that would give you x. Another way to think about it is what squaring means, which is to multiply by itself. So if you took root x times root x, you can multiply what's underneath. You'd have the square root of x squared, which is really the same expression with the square and the root kind of interchange, but still giving you x. So the reason it works is because of this, but we can just think about square root, squared, opposite operations, and it eliminates. So squaring all these expressions, and they're just a little bit different expression in each case, so we want to see how the squaring would be slightly different. Here, when I square it, we'll get rid of my square root, so I would just get what's underneath. That's one of the steps in solving I'll get to in a minute. Here, when I square, I have a two-term expression, which actually means I have to FOIL this, so I've got to multiply it by itself. Foiling with that root of x in there should be no big deal. We'll just do the first outside, inside, last, the way we always would, or box method if you prefer that. But here, root x times root x gives you just x, which I was talking about up here. That's why we discussed that a little bit. And then your outside, inside terms, and then your last term, and then combine the middle terms, and there's your expression. Now, comparing these two, having that 2 out front, actually very similar. When you go to square, it's like a distribute idea. So you're going to square the square root, but you're also going to square the 2. So now you have 2 squared is 4 times x minus 4, and then distribute that in 4x minus 16. And then 2 roots, well, when you go to square that, again, that becomes a FOIL. And when you do root x times root x, like we showed you up here, you're going to get just plain x. And also when you do root 5 times root 5, you'll get just like we showed you up here, but it'll be 5. And then your inside, outside terms, and then combine some like terms. So the purpose of those 4 problems is to show you how, depending on how you're squaring your terms, the expression can be quite a bit different in what work you have to do. Okay. Other thing to remember too is some radical thinking. So let's think about what happens when you try to answer these questions. So what would you square to get 4? 16. What would you square to get negative 4? Now we talked about that as not being possible, right? You can't take the square root of any number and produce a negative result. But let's say I have this equation and I square both sides. Now x equals 16. But a minute ago we said the square root of 16 cannot equal negative 4. So what that means is when you start squaring both sides in your work, sometimes you may actually get a solution and not realize that it really doesn't work in the original equation. Right? That being this one right here. So we'll have to check our solutions as part of our process. Okay, let's get into solving. So some steps over here to the side. You want to isolate the radical first, which means get the root part of the equation alone. There can be nothing else attached to it. So for example, this negative 5's got to get moved, that 10's got to get moved, that negative 5's got to, or that 5, excuse me, and negative have to get moved. Get it by itself, square both sides, then just do your normal solving, and last but not least, don't forget to check. So we're going to start in this one by squaring both sides. Again, square root, squared, opposite operation, so that will eliminate. You got to square that, so x squared minus 3 equals 16. Algebra here is pretty straightforward stuff. I mean, once you get rid of that root, this is easy algebra. And then comes a check. The check amounts to you taking that solution and plugging it back into the original and seeing if it gives you a true statement. So 19 minus 3 is 16, square root of 16 is 4, 4 equals 4, checks out. Pretty good starter problem, basic work right there. You get rid of your root and go, and then don't forget to check. So like I said here, we're going to have to clean off this negative 5, which means adding 5 to the other side. So we got 9. Now I'll go ahead and square both sides, which will get rid of your root. Make sure you square this side also, and then do a little bit of basic algebra, and then that's your answer, and then you want to check your answer. So I plug 79 back into the original equation, then I just run through the numbers and make sure I get a true statement. So when you get done, if it's a true statement, that's a check, like yes, that's a solution. We'll just keep doing a couple more. Here we go. Let's get that 10 out of there, move that 10 to the other side, subtract 10 to the other side. Get rid of your square root, excuse me, by squaring both sides. X is 144, and then go to check. Now, there's something that happened here that I could have probably figured out much earlier, but I did this sort of on purpose to you guys. So if I plug that 144 back in, that's 12, I get 22. 22 does not equal negative 2, which means there's no solution. But actually, back here, before I went and squared both sides, if I was just working on this part right here, I could have stopped right there and said that's a no solution. Because again, what can you take the square root of and get a negative result? you can't. So if you could recognize this right here, just stop. If you didn't and you went ahead and did the whole process, the check should also show you no solution. Okay, one last one before we switch a little bit on the problem. So subtract the 5 to the other side. That's really a -1 times the root, so we're going to divide through by -1 to get that out of there. Now I got the root isolated, square both sides. That'll get rid of your square root. And then a little bit of basic solving, and then your check. And so again, the check just amounts to you taking that x value, plug it back in, run the numbers, and see if you get a true statement. So there's some variation on different types of root equations. They're fairly easy to do. It's just that you do that check along the way. Okay, we're going to do one more like this, then we're going to switch to a little bit different problem. This one seems kind of harmless at first, right? I actually can start by squaring both sides. The root is already sitting by itself. Square both sides, that'll drop the root. When I go to do this, squaring a 2-term means FOIL, right? Multiply this thing by itself. So that's going to create a little bit more work, but let's just run through the process. So got rid of my root, I got a FOIL, so that's next. There's my FOIL. I'm going to clean it up a little bit, combine my middle terms. Then really what I should do if I'm trying to solve is get everything on one side equal to 0. So we're going to start peeling stuff off here. Actually, I reorganize this just to look more like we're used to. X squared x number. Subtract the 16 over to the other side. So 1 minus 16, negative 15. Add the 8x over. We're trying to get it equal to 0. That'd be added to this term. And then I want to try to factor. Now I've got my factors already set up, ready to go. But remind you guys from previous sets of notes what I want to do there is check the factors of 4 with the factors of 15. And in what combination would it take to produce the middle term. And I'm not showing you guys every single possible combination to save a little bit of time in the video here, but it would be a little bit of messing around until I get that middle term to show up. And here's what happened. I got an outside term of positive 10, an inside term of negative 6, and positive 10 and negative 6 is positive 4. And then I can set my factors equal to 0 and solve. Now, there's a check going on here too, so we got to do some checking for this. So you'll see the work for the check. So there's my solution. Again, set my factor equal to 0, solve. Plug that into the original problem, both spots in this case, because there's 2 x's in the original, and start going through the work. Turns out I just stopped here because I figured at this point we'd understand the idea of the square root of 4 can't produce a negative, square root of 36 can't produce a negative, so no solution. So it turns out that neither one of these is a solution. This is a no solution overall. There will be no answer. And what no solution means is that you can't take the 3 halves, plug it into the original again, and get it to work out. And you can't take the negative 5 halves and plug it back in and get it to work out. So no solution. Okay, a couple more to go here, and we'll wrap it up real quick. So we're going to do kind of a twist on the distance formula. So distance formula, which is something you guys would have learned way back on, that might be as far back as pre-algebra. Given 2 coordinates, find the distance between them. Basically, a lot of times we use this we have this formula written a little bit different. We'd have like x minus x2 minus x1 and y2 minus y1, but this is the way this book describes it, so we're going to use the A, B, C, D letters. But what you do is you go x minus x, y minus y, and then square those two and add them together. So we're going to stick to that pattern. We're going to turn it into kind of an algebra problem where part of a coordinate, 4 comma, I don't know. In this case, it's calling it x. Now, don't confuse that with being like, why is that not a y? This book just happened to put an x in that spot, but just go with it. And then 3 comma 3, and then is x plus 2. So the distance between these 2 points is. Now, I want to create kind of an equation out of that. And I'm going to kind of go in lumps of work here. So what I'm going to do is I'm plugging in. So I took my 4x, 3, and 3, and I plugged into here. So you'll see my first one is 3 minus 4. There's my c minus a. And then my second one is 3 minus x. There's my b minus d. Whatever they are, right? Don't be concerned about this being x here. And then the word is an equal sign, and then there's the distance. So this expression produces a distance. Then I'm going to start cleaning it up, which is square that, multiply it by itself, which becomes a FOIL for that little piece. And here I'm just cleaning up the numbers. So that becomes negative 1 and 1. There's the FOIL. And then all this stuff kind of reorganized a little bit better. So I combine my like terms, combine my number terms, reorganized. Now, this would be similar to what I was showing you guys before, where I got the root by itself. So what I want to do now is square both sides. And that'll drop the root. And then I'm going to show you another chunk of work that kind of goes through some more cleanup. So we're going to bring, the root is now gone, and bring that with for a while. This is a FOIL problem, so there's the FOIL, all the pieces of the puzzle cleaned up. And then after this, what would happen if we kept going is the x squareds would actually drop. So the next phase of this is the x squareds are gone. They just drop out because you have the same thing on both sides. And then I'm going to go to basic algebra to wrap it up. All that work into my x equals negative 3, which means that value would be negative 3 to satisfy the equation. So I plug a negative 3 in and run the work, plug a negative 3 in here and here, I'd get a true statement. Okay, that's the end of your 5-7 notes.